Hey there, and welcome to C5BoardNotes.com. All right, this is Mikhail Francha, and we're going to continue the series of the 152 when you by going ahead and talking about this next one over here, the flight controls of the plane. Now, after airplane familiarization, second page is flight controls, and as far as going through the students and explaining these things to first timers, especially with the student pilots, flight controls can be relatively difficult to understand, but I kind of liken it to throwing darts, for example, or with the goal of hitting a certain target that is far away from you. So, if you had two choices in front of you, which is going to be the dart or something heavy like a bowling ball, which one would you naturally choose in order to, you know, hit the target? Right? Naturally, they would go over to the dart, right? Not only is it lighter, but with the relative shape that it has, it's relatively long, light. It's got these fins that allow you to put some spin into it. Also allows it to fly further. This seems like the perfect choice. And why don't we use the bowling ball? Well, first of all, it's heavy, right? That makes sense. But even by its general shape, that's not really meant for long distance throwing. Well, in this example, all right, so definitely the target or the dart would be a lot more accurate. So I like to come in, explaining that to them, and just letting them really understand it. Specifically, as far as the dart is concerned, you know, assuming this tip, I can't really draw darts that well. How these fins over here work, right? Now, before we go over it into specifically, right. We will have the Know Your 152 section, which dives into what the POH specifically says. And, as far as the check ride is concerned, these are things that I expect the DPE to be asking you. And you better, be familiar with this if you want to pass a system section. All right, so based on the POH, right, has a conventional aileron, rudder, and elevator control surface. The aileron is what will control the roll. The rudder controls the yaw, and the elevator is for the pitch. All right, that's what you want to know. And as far as actually controlling these things, this is manual operation, so that means no autopilot via mechanical linkages. So what does that mean? It's essentially, you have your yoke, which is a control wheel, and the rudder pedals. They just connect to it via wires, right? Via these long, strong, thin wires. And the yoke, which we'll just get ahead and show it to you. This is the yoke, and these are the rudder brake pedals. The yoke controls the ailerons and the elevator. The rudder pedals naturally control the rudder. Now, as far as the flaps are concerned, we have single slot flaps with max 30 degrees of deflection. Right, they're going to be four settings. One is the 0 degrees, then you have 10 and 20 and 30 degrees, which is going to be full. Okay? And alternatively, this is going to be controlled electrically instead of manually. This is the only one we can control electrically, and that is via a 15 amp circuit breaker. Okay, so let's go over the flight controls. When we talk about flight controls, this is how you are able to allow the plane to do certain things. If you want your plane to climb, if you want your plane to descend, if you want your plane to, turn, if you want to turn over to the right, you use your flight controls. And there are two settings, or there are two different kinds of flight controls. And one would be the primary, which are going to be the blue surfaces, right? All this stuff over here. And you have your secondary. The difference between the two is that, as you can see with the name, primary flight controls are the ones you are supposed to be using the most. All right, these are the main controllers of your roll, your pitch, and your yaw. Secondary, such as flaps and the trim tab, which is really the only two secondary flight controls we have for this plane, is what we can use to help us maintain certain settings. So, for example, I use my trim tab to help stabilize my cruise, right? So, for example, if I want to control my altitude, let's say 3,000 feet, that would require me to kind of use my yoke up a certain level. Like, if, for example, I need to like pull back my yoke, a certain kind of pressure throughout that whole flight, it's going to be hard in my arms, and it's going to make everything a bit harder. But if we add some trim, what that does is that it kind of sets the amount of pressure you're putting onto your yoke. All right. So, and for the flaps, that just helps with the landing, and we'll go specifically with the flaps later on. The ailerons, now these things are over here, and what they do is when you turn, for example, one goes up and the other goes down, right? There will never be a situation where both go up, right? No bueno. With ailerons, what you're doing is that you're creating a difference in lift. For example, if I want to be able to, let's go ahead and set that up. If I want to be able to turn, right? We're looking at this section over here. I have my yoke, and if I want to control my yaw, I'm sorry, my roll, I'm going to move my yoke over to the left. So it's kind of like you're driving a car and you're moving it to the left. What that does is that it allows the left aileron to go up and allows the right aileron to go down. What that does is that it creates a difference in the angle of attack, right? So you're going to have a much higher angle of attack over here as opposed to a smaller angle of attack. What that does is that it creates much more lift over on the right wing. So in essence, if this gets more lift, and this gets less lift, that's going to allow you to start turning the plane. That's essentially how it works. And that is going to be controlled with the yoke, right? We talked about it's via the roll. And for everything, the yoke, as you can see, controls the elevator, controls the aileron. The rudder or the brake pedals control the rudder over here, and the brake pedals, which are going to be down at the bottom. The top part of the pedal is going to be used for braking, and you're going to essentially move the whole step if you want to move the rudder, or if you want to steer the plane when you're down the ground, when you taxi. All right, second thing we're going to be talking about would be the elevator. And the elevator controls pitch, which are these tiny things, which is controlled via these things over here, right? So the elevator works the same way, all right? You're creating a difference in the angle of attack. So when you pull on the yoke, whether you push it up or down, it creates a change in the elevator, right? Either increases or decreases the amount of lift in the tail. So you want to think about it this way. If I'm increasing the lift of the tail, what's it going to do to the rest of the plane? Personally, if you increase the lift here, that allows the plane to kind of point down. If you decrease the lift, or not really making it go down, but if you decrease the amount of lift relative to the rest of the plane, that's going to allow the plane to then pitch up. So you really are just changing the shape of the tail. A decrease in AOA when I pull the yoke back allows the tail to go down. Like what we talked about. If the tail goes down, the general setting of the plane would then go up. Now we are going to move over into the other side of the empennage, which is going to be the horizontal elevator, right? So this part over here, or the second part of the tail, I meant. And that, like what we talked about, is controlled via the rudder and the brake pedals. Sorry, not the elevator, I'm talking about the rudder. And anyways, So you have your rudder and brake pedals over here. So for example, I'm up in the air, I'm flying at cruise, and I'm gonna start pressing over on the right side. What that does is that it kind of swings the whole rudder over to the right. And think of it as if you got an elevator and kind of just switched it so that instead of being horizontal, it starts going vertical. That's what it is. So you're just generating a change in, you know, the left to right lift. That's the simplest way to kind of explain it. So that's why we have the lift here in parentheses. So what that does is that when I press on the right side or the right rudder pedal, that pushes the tail over to the left and allows your nose to move over to the right. Yes, okay. So you have the rudder moving over here. What that does, since we're talking about the lift, is that it generally allows the tail to move over to the left. And thinking about what it does to the rest of the plane, is that if this part moves over to the left, the nose of the tail would then move right, or it's going to rotate to the right. Okay, so that's how the elevator works. And so those are the primary flight controls. Like we talked about, we got the aileron control system, elevator control system, and the rudder. Now, as far as going back to the elevator, we also have the trim. Like what we talked about, this kind of just helps the pitch, right? And manually operated via what's called the trim wheel, which is going to be right between the two seats. So like what we said, what it does is that it just maintains the pressure of the yoke. If I'm pulling the yoke a certain way with a certain amount of pressure in order to maintain my straight and level, what that does is that it relieves the amount of pressure I'm putting on my yoke. So this is the closest thing we really do have to an autopilot. And it works very simply. So if I want to pull up or if I want to make my nose go up, I'm just going to rotate a couple of times down on the trim wheel. If I want to pitch down or reduce the upward pressure, I'm going to roll it down. You have a certain setting that you want your plane before every flight. There's a certain setting where it's officially at cruise or it's straight and level, and you always want to start off with that because that's the standardized setting of the trim, right? That's when it's completely flat. Because if you take off with a certain amount of trim already, you could be taking off with a trim like this or like that over by the tail, and that's just going to affect the rest of the way you fly. So just make sure you keep in mind to standardize the trim or set the trim up during your pre-flight. So that would be the secondary. And the last secondary flight control system that we have would be the flaps. All right, we have those over here. And like we talked about, single slot type with 30 degrees max deflection. Especially when they talk about flaps, they really ask about two specific things, which is the ones we've highlighted, electric flaps and single slot. Anyways, you control it via a motor in the right flap. So it's all electrically connected over here. This one is like the master flap, I guess, because that's where the motor is. And it just attaches over to the other flap over here, and that's what allows both of them to go down. So with the aileron, if one goes up and the other goes down, for example, it doesn't work the same with the flap. One goes down, the other goes down. One goes up, the other goes up. And they both better be working the same way. So if one is 10 degrees, the other one has to be 10 degrees as well. And what that allows you to do essentially is that it allows you to lower your landing speed, which is going to essentially lower your landing distance. And especially when we start thinking about short field landings, for example. That's why we like to use flaps. For example, this is going to be the runway. The more stable your speed is, assuming you're not at below VG or below the landing speed, that allows you to have relatively relatively less float. If you're going faster, you might, once you start rolling out here or leveling off, you might land here. But if you're going at a relatively slower speed, you might actually reach your point, which is going to be in this area. And the second one, I think, is one of the more important things as well, which is it allows you to increase your descent angle without increasing your airspeed. So, for example, if you want to stabilize at 60 degrees, but 60 knots, but you have to get down to the runway, the flap increases the descent angle. Okay? And especially, and the last reason is that, especially when it comes to short field and soft field takeoffs, is that it allows you to decrease your takeoff distance. So without the flaps, if it would take you all the way up to here to take off, with the flaps maybe over here, which really helps for the short field. And it also helps for the climb angle as well. So just relatively to put it basically, what it does is that it allows you to increase the amount of total lift and the amount of total drag onto your plane. We really use flaps as far as flights are concerned with getting yourselves as stable as possible over onto the landing. And that's something we can go ahead and talk about when we talk about the actual aerodynamics and why it's especially important for us. So that's the flight controls. I mean, I tried to explain it as simply as I could. And I really would suggest that you go over the rest of the notes, check out the rest of the book if you need some further explanation. As always, check the website for the actual notes over at c5boardnotes.com. So check us out there, check the downloads. And if you have any questions, don't hesitate to drop us a comment. Send us an email, just let us know what you think. All right, not going to be perfect, but this is how I would personally teach my students when it comes to the flight controls. So yeah, have fun and enjoy the rest of your day.